Hi. So today we are going to take a lecture on kinematics, and we are starting with the first equation. We are basically dealing with graphs only, and that those two are only of kinematics. So graphs of kinematics can be divided into these topics. I mean, if we are talking only about the graphs of kinematics, then we have, say, the first equation. So we have, say, first equation, and then we have the second equation, the acceleration position graph variate, sign of acceleration from position time graph, average velocity. Today we will be dealing with only the first equation. Okay, so what is first equation? First of all, we have, say, a equation of this kind, v equal to dx by dt. This we call the first equation. For kinematics purpose, this is the first equation which we will be dealing with. What does this equation give? First of all, it gives, we say, v is, I don't know how to rub it. We have, now we have v equal to dx by dt, and what does this mean? This means that the slope of the position time graph is instantaneous velocity. Okay. Now, if we take the dt to the other side, just a moment. Now, if we take the dt to the other side, we get v dt equal to dx. Now we can further integrate it. Now this is another way of writing the same equation, and it means that the area under the VT graph is change in position. Now this can be further extended to average case, average speed. I mean, speed case, speed is rate of change of distance with respect to time. I mean, while we have v as a vector quantity, we know v is a vector quantity, and here this is also a vector, this is vector, this is vector. When we deal with speed is distance, rate of change of distance with respect to time. So we can say, like, we have v vector bar mod equal to dx vector by dt mod. Now further changing it to integral form, we get v vector mod dt integral equal to dx vector mod. Okay, so this is speed relation. Okay, so we have our first question. We'll be dealing with only vector form questions. On a distance time graph, two straight lines make angles of 30° and 60° with the time axis. The ratio of velocity is represented by them as 1 is to root 3. 1 is to 3, 2 to 3 is to 1, 3 is to 1. So this is the question. So we first of all draw a displacement time graph. We have, say, we have two straight lines. Two straight lines, one at 30°, this one is 60° and this is at 30. Approximately, we don't need to take scale or actual angles. We can just make a graphical pictorial representation that this is the approximate angle for our analytical purpose. For when we need to draw the actual graphs, we draw them. to scale, but while solving IIT JEE questions we can do it and roughly correct figures. So the ratio of velocity is represented by them is now this now this angle is 30 degrees is, and this angle is 60 degrees. So what are the ratio of velocities presented to them? We know that velocity is the tangent of angle of inclination of the displacement line graph. This is a displacement line graph. This is displacement. Here we have. So we have this slope is tan 30 and the other slope, this one is tan 60. So the ratio of velocity would be this ratio. So tan 30 is 1 by root 3, tan 60 is root 3, this is 1 to 3. So this is the correct answer. Now a body is moving in a straight line as shown in bigger velocity time graph. The displacement and distance traveled by the body in 8 seconds is respectively. Now how do we find this? Now we have to find the displacement and distance. Now first of all, we have, for finding displacement, what we'll do, we'll take the signed areas. Okay. This area is, we know displacement is area under the BT graph, right? So this area is 4 into 2 is 8. This area is 2 into 2 4, or actually minus 4, and this area is 4 into 2 8. So the total area would be 8 plus 8. Now in calculating displacement, what we'll do 8 minus 4 plus 8 equal to 12, and in distance what we'll do, we'll take the areas without sign. So we'll do 8 plus minus 4 mod plus, or so displacement is 12 and distance is 12. So A is the correct answer. The graph shows position of as a function of time for two trains running on parallel tracks. Which statement is true? At time t, both trains have the same velocity. Now, how do we find out velocities from this graph? We know that the slope of the B graph would be the velocity of train B, and slope of A graph would be velocity of train A at the instant t. Now we know that slope of A is more than slope of B. So at time t, both trains have the same velocity. Is it true? No. Both trains have the same velocity at some time after t. Now we know that this much slope train A has a constant slope. Train A has a constant velocity. So for getting this velocity, if they have train A and B have equal velocity at some time, we say that we'll have to find the instant when both have same slope. So how will we do it? We'll draw a line parallel to this line parallel to the slope of A and see where it becomes tangent to B. Here it is correctly drawn. So at this point the line parallel to velocity of train A has become tangent to B. So both trains have the same velocity at some time before TV. C is the correct option, and somewhere on the graph both trains have the same acceleration. Now acceleration, what is the acceleration of A? It is 0 because it is moving with constant velocity. And does the acceleration of B ever become 0? No. So C is the only correct option. Then we have another question. The velocity time graph of a particle in linear motion is shown in figure. Both V and T are in SI units. The displacement of the particle is, we have to simply calculate the area of this trapezium. This trapezium area is half into sum of parallel sides 2 plus 4 into height 4, so 6 into 24, 12. So the first area is 12, second area is 4 with a minus sign and into half and 4 into 2 plus half into 2 into 2 plus equal to minus 6. So we have 6 is the displacement. So answer is given to be 12. Be done wrong somewhere. 6. Are we supposed to do half also? Yes, we have to do it. So there is some error in the solution. I'll correct it in the book. The area of the trapezium is half should be multiplied in both cases. So the displacement is 12 minus 6. Fine. Good enough. Okay, one more question. The speedboat starts from rest, accelerating at 2 meters per second square from 20 seconds. It then continues to steady speed for 30 seconds and decelerates to rest at 30 seconds. Find the distance traveled in meter, the average speed in meter per second, the time taken to cover half the distance. Now displacement here is the area under the graph, and the distance is also the same because we have only the graph in positive quadrant. Okay, so what is it? It is calculated 27.5. Here it is calculated. Okay, then the average speed in meter per second. Average speed is total displacement upon total time. So the total time is 80, displacement divided by 80 is average speed. Oh, displacement is 2200. 2200 divided by 80 is average speed. And the time taken to cover half the distance. Now half the distance is 1100 and time taken to reach such a, we need such a time instant so that the area under the graph is 1100. 1100 equal to this area under graph up to 20 seconds is So we can simply do it like this. We'll do 1100 equal to area up to 20 is 40 into 20 into half plus t minus 20 into 40. Okay, so this gives 1100 equal to, this is 400 plus 40t minus 800. So this gives 1500 equal to 40. So t equal to 1500 by 40 equal to 1 plus 0 by 4 is, yes, answer is correct. That is not fine. So this is all. These are all the questions of first equation. Next time we will be doing second equation. This is chase diagram created by Krishna. Now we have second equation also. We'll do it next time.